Alright, so we're on test 5 of McGraw-Hill's 10 ACT practice tests, second edition. Question 1. Which of the following lists all the possible factors of 32? Alright, so let's see, we have 1 and 32, we have 2 and 16, and 4 and 4. 4 and 8. Am I missing any? I don't think so. So 1, 2, 4, yeah, this one. All CDs are equally priced. If 8 CDs cost this, so 8 CD cost $76. What is the cost of 1 CD? 1 CD, X dollars, right? So once you set up the proportion, you could then remove the units, and you can cross multiply to find the answer. So 8x equals 76, divide by 8, and you can grab your calculators and do 76 divided by 8, and you get 9.5. Alright, so for this one, we want to combine the number parts first. So 2 times 3 is 6, 6 times 5 is 30. We're going to eliminate those. X squared times x squared is x to the 4th. X to the 4th times x squared is x to the 6th. Okay. And then, yeah, the y would be y squared times y is y to the 3rd. We add the exponents there. What is the value of the expression this when x equals 50? All right. So we have 10 times this quantity plus 100, and you want x equal to 50. So you could just plug right in. There might be a slightly faster way, but that's not that important. Let's see. I mean, the first thing I would do is I would distribute this 10, right? So doing that just puts an extra 0 on each piece. Alright. And then from there, you can factor out 100, and then you'd be left with, alright, 2 less zeros here, and then 2 less zeros here. So that's 1, 2, 3, 4. And then plus just 1. Right? And then you can plug 250 in for there. So anyway, 250 times 10 is 2,500 minus 10,000 plus 1 times 100. So this would be negative 7,500 plus 1 times 100. Am I doing this right? Yeah, it doesn't seem to be right. So let me just do it the simple way. Alright, just plug in an x. So starting on the inside here, we'll get 100 times 250. Alright, and then we subtract 10,000. Subtract 10,000. That gives us the parentheses. Now we times that by 10. Oh, I think that's where I went wrong. Okay. 150,000, and then add 100. And 150,100. Alright, so here we do 4 times 5, we get 20. 8 to the 3rd, 8 to the 8 is 8 to the 11th. So that's D. Figure shown below, AD is equal to 16. So that's going to be this whole bottom piece. ED is 11. So that's this piece here. AE is congruent to CD. Okay. What is the length of AB? So we want to know this piece here. Well, let's see what else we could figure out based on this. Looks like this piece is going to be 5, and so is this. The reason why I know that is because 16 minus 11 is 5. They both end at the same position, so they start at different positions. The difference is basically AE, and that's 16 minus 11 is 5. And since these are equal, that's 5 as well. So then we know that this is also 5. And if we have 5 and 5 in a right angle, this is going to be 5 radical 2, because we know this is a 45, 45, 90 triangle, which of course has the ratio of sides x, x, x rad 2. Now if you didn't know that, you can also use Pythagorean theorem at that point and do 5 squared plus 5 squared, take the square root. So you get the square root of 50, which you can simplify into rad rad 25 times rad 2, and that's 5 rad 2, of course, right? Which of the following numbers is least in value? So here we're looking for like the sort of smallest decimal place. So if you swing this out 4 times, 1, 2, and then you're going to have 2 zeros behind it, so it's going to be 200. Here we got to swing this out 3 decimal places to the right. So that's 1 and then 2 more zeros. Here we swing the decimal twice to the left, so 1 and then a 0 in front. And then here we swing it to the right, we get 2 extra zeros on top of the 1 we already have, so that's 3 zeros. And then here we go 5 times to the right, so 1, 2, 3, and then 2 more zeros. So the smallest would be choice C. The isosceles triangle below has one angle measure as shown. What is the measure of each of the other angles? So we know they're going to be equal because it's an isosceles triangle, so the base angles are equal. So we can make a equation where this adds up to 180. So we get 2x plus 50 is 180. Subtract 50, we get 2x equals 130. Divide by 2, you get x equals 65. The sum of the real numbers a and b is 13. Their difference is 5. So right away we can sort of find what a and b are using an elimination method. In this case I'm going to add the lines. I get 2a is equal to 18. Therefore I know that a is equal to 9. Alright. Then when I plug back in, let's say to the original equation, we get 9 plus b is 13. Subtract 9, we get b is equal to 4. So the question is asking for a times b, so 9 times 4 is 36. Alright, 37 is what percent of 144? So notice I used the Math English Dictionary there, where is equals, of is times, percent is divided by 100. Alright, so from here, a more standardized way of writing this is 144x over 100. Okay, and then the idea is to isolate for x, so I can actually move the 100 vertically, or sorry, diagonally across the equal sign, and I can do the same thing with the 144, moving it diagonally downwards across the equal sign. Then I get sort of x equals this, and I could just use my calculator from there. So 100 times 37, and that divided by 144. So you get 25.6, which is approximately 26%. The Moondance Riding Academy held its annual horse show for 3 days. The total amount collected in entry fees for 3 days was $14.50. The amount collected in dollars shown, approximately what percent? Okay, so they want a percent, which is going to be part over whole times 100. Now we already saw the whole is $14.50 for the 3 days. Okay, so now we just need to consider what part we're doing. So what percent of the money collected from entry fees over the 3 days was collected on day 2? So day 2's amount is just about 500. And so we consult the calculator here. 500 divided by 1450 and times that by 100, we get 34.4. The mean, which is average, collected per day is what? So we know that average equals sum over number. We know that the sum was 1450. We know that there were 3 days. So we just do 1450 by 3, 483. For all n, 3n plus 5 squared equals. Okay, so here we multiply the 3 n's. We get 3 times 3 is 9n squared. Then 3n times 5 is 15n. And we do the inner, and then we do the last. So we have 9n squared plus 30n plus 25. So that's choice E. A certain brand of cereal costs $3.25. $3.25 per box before sales tax is added. When you buy 5 or more boxes of cereal, you receive 1 additional box for free. What is the average cost of a box for 6 boxes? Okay, so let's see. If we buy 5 boxes, let's see how much that's going to cost. So if we multiply these together, boxes will cancel to get us dollars. So let's see. 325 times 5 is $16.25. So that's how much it costs for 5 boxes, but then you get the one free. So this is really the cost for 6 boxes. So if we divide this by 6 boxes, we'll get the average cost per box, dollars per box, right? So divide that by 6, and you get 2.70. So that's choice G. R&T own a pizza shop which offers 3 kinds of cheese, so right away you know it's counting principle. Each type of pizza on the menu has a combination of exactly 3 ingredients. What type of pizza are possible? Alright, so just do 3 times 4 times 5, right? 3 times 4 times 5, 20 times 3 is 60. On the real number line, what is the midpoint of this? So the midpoint is just, you combine the numbers and divide by how many there are. So 11 minus 3 is 8. 8 divided by 2 is 4. Which real number satisfies this? So this is a base problem where we notice that 8 is a sort of pure multiple of 2, right? It's 2 to the 3rd power. If you didn't know that, you can factorize it. 4 times 2, 2, 2, 2, right? So we replace 8 with 2 to the 3rd, and same thing with 16. That's just 1 extra 2. So that's 2 to the 4th. So we also replace that with 2 to the 4th. Then we notice that we can add the exponents on the left side. That's rule 1 of our exponent rules. And then here we have rule 3 of our exponent rules, which is the multiplication if we have a power to a power. Then the 2's will drop out, and we can set the exponents equal. And then we subtract 3, giving us n equals 9. Alright, so here we want to plug in minus 4 wherever we see x. So get this for the value. So negative 4 squared is 16 times negative 3 will give you negative 48. Minus 8 is going to give you negative 56. Clock tower casts a 150-foot shadow. Angle of elevation. Alright, so they want the height, right? And so we can just sort of use this ideas. Okay, so from the perspective of the angle that we know, we're looking at here the opposite side, right? And here this is the adjacent. So really the relevant function is tangent, because SOHCAHTOA, tangent, opposite over adjacent. So the tangent of 40 is the opposite, which is h, over the adjacent, which is 150. So I just simply move the 150 across diagonally, across the equal sign, and I find h equals this. And then I could plug the tangent of 40 in. That's convenient. So 150 times of 0.84, that gives 126. Alright, so here we just have to distribute the 4x minus 8 plus 5x, and then distribute the 3x plus 9 minus 11. And let's see, well, plus 9 with minus 11, that makes it minus 2, right? And then we have 4x and 5x, which makes 9x. Then we could subtract 3x. That gives you 6x. Minus 8 equals minus 2. Then we add 8 to both sides. We get 6x equals 8 minus 2 is 6. Divide by 6 on both sides, and you get x equals 1. What is the least common multiple of these numbers? 40, 70, and 60. Okay, let's think about how we want to do this. Alright, so firstly, we know that they're each sort of got a 10 at the end. So, yeah, what we could do is we could find the least common multiple of these numbers, then sort of stick a 0 at the end of it. But if you don't like that, well, alright, let's try that first, right? So let's say we're doing the least common multiple of these guys. One way to do that is to look at the prime factorizations. So 4 is 2 times 2, 7 is already prime, and then 6 is 2 times 3. And now we can make a list. So 4 is 2 squared, right? 7 is just 7. And you'll see why I'm sort of doing it this way. And then 6 is 2 times 3. So what I want to do then is I want to make a complete list. So this has got, right, so this is the representation of 4, 7, and 6. So the 4 has got, 0 copies of 3 and 0 copies of 7. This has 0 copies of 2 and 0 copies of 3. And this one has 0 copies of 7, right? So now if I want to find the least common multiple, what I have to do is I have to find the greatest of each column. So here I'm looking at the 2's and I'm finding 2 squared. I'm looking at the 3's here, I'm finding 3. Looking at the 7's here, I'm finding 7. Okay, so I'm taking the greatest exponent in each column. And then I just simply have to multiply these together. So 2 squared is 4, times 3 is 12. And 12 times 7 is, I believe, 84. And then we have to remember that we sort of disregarded a 0, so we have to put that 0 back in now. Okay. Alright, so here we have an equation with sort of mixed numbers, and it's always better to work with improper when it comes to this stuff. To change it into improper, you multiply these and then add the numerator. So it would be 20 plus 2, 22. So this would turn into 22 over 5. Then same thing here, you get 1 times 3 is 3 plus 2 is 5, so this turns into 5/3, okay? And then to solve this, you have to add 5/3, right? So we need 22 over 5. Whoops. 22 over 5 plus 22 over 5 plus 5/3. And we get this. If we want it as a fraction, we can do math, enter, enter. So we get 91 over 15. 91 over 15, which is G, right? System of linear equations shown below, which of the following describes a graph. Okay. Let's see. So ideally we'd have them in y equals form, right? So to do that, we would have to sort of move these to the other side. So this would become a plus 2x, and moving this, it would become a minus 2x, right? Then we'd have to divide by 4 on every single piece. So the first equation we would get is y equals, so sort of 1/2 x plus 2. And here we would get y equals negative 1/2 x plus 2. So what we learn here is that the slope here is 1/2 and the slope here is negative 1/2. So it's not a single line, it's two separate lines. And they are distinct, meaning different, and they do intersect because the slopes are not the same. So since the slopes are not the same, they're not parallel, right? A house painter charges $24 per hour for painting job that requires more than 5 hours to complete. For any job of 5 hours or less, so if we let x equal the number of hours, this is for x greater than 5. For any job that takes less than 5 hours, the house painter charges a flat fee of $100. Okay, so it's kind of like a piecewise function. If n represents the number of houses the job requires, which of the following expressions gives the charge in dollars for a job requiring more than 5 hours to complete? So we're kind of in this category now, right? $24 per hour, we times it by x hours. Okay. So it's going to be, let's see, just 24 times x, right? Yeah. The average of A and B is, alright, so remember average formula, which is sum over number. And they're telling you the average of A and B is 6. So we know that the average part is 6. And what we do is we add the numbers together and divide by 2, right? So whenever they tell you the average of a and b, we always do a plus b over 2, right? That is 6. The average of a, b, and c, so this time we add all three of those together and divide by 3, and that is going to equal 11. And they're asking us to find c. No problem. So we have to remember one thing, that whenever we have sort of more than one term in a long division bar, we do this with the parentheses, right? And now we have to multiply by 2 here. So we get the fact that a plus b has to equal 6 times 2, which is 12, right? So that's going to be useful for us here, because, again, so we move the 3 over, and then we get 11 times 3, which is 33. Right, that's the sum of a, b, and c. Now I could drop the parentheses. I don't need them anymore. Okay. What I do here is I plug 12 in for the total of a plus b together. Okay, so you get 12 plus c equals 33, then subtract 12, and that will give me c is equal to 11, right? Sorry, did I do something wrong here? Sorry, yeah, this is 21. Whoops. Okay. In the figure above, OS equals ST, right? And the coordinates of t are k comma 5. So it over k and up 5, which to me means, right, if this is 0, 0, we need to go over by amount k and up by amount 5. What are the coordinates, sorry, what is the value of k? Well, k would have to be 5, right? Because assuming that these pieces are equal, they both have to be of size 5, so k would have to equal 5. At a summer camp, one boy and one girl will be selected to lead the activities. If there are 130 boys and 145 girls, how many different two-person combinations? So one way to do this is you do 130, choose 1 out of the boys. And then you also do 145, choose 1. Okay? So 130, choose 1, we could put into the calculator, right? So you can kind of go 130, then you go to your math menu, you go over to the probability menu, NCR, and then 1. You get 130, right? That's kind of silly to do this, but I just wanted to show you where that was in the calculator. So instead of interpreting it as 130, choose 1, there's another way you could think of it. How many ways can I do for the boys? Well, it's 130. How many ways can I do for the girls? 145. I have to do this and this, so it's multiply, right? So that times 145 equals 18,850, right? Yeah, so this is counting principle, right? So here we use combinations, here we use counting principle. Let's think for just a moment, though, because when we use counting principle, do we count both arrangements? Let me think for just a moment. Oh, it's actually fine, right? It's fine because of the choose 1. So that's what makes permutations and combinations equal if there's a 1 here, because then I would divide by 1 factorial. Yeah, okay. So what I was just looking for there is, usually it's the case that counting principle, right, is equivalent to permutations, not combinations. But it's also equivalent to combinations in the case where we have a 1 there. Okay. If 3 times a number x is added to 12, the result is negative. That means this. Which of the following gives possible values? Okay, so we minus 12. So the setup there was kind of the hard part. And then divide by 3. So we get x less than minus 4. Choice G. The figure below shows 2 tangent circles such that the 9-inch diameter of this is equal to the radius of the larger. Which is the approximate area of the shaded region? Alright, so we need to find the area of both circles and then subtract. So let's go for area of the big. It's going to be pi r squared, where r here is radius of the big. So radius of the big is 9. So we plug that in. 9 squared is 81. So this is 81 pi. Now the area of the small is going to be pi r squared as well. But this time we're going to use the small radius, which is half of the 9, 4.5. 4.5 squared is, I believe, 20.25. and so we get this for our smaller area. Now we have to subtract those values, so we go to the calculator and we get 81 times pi minus 20.25 times pi. That's going to be 190.8, choice D. Alright, so here we're going to have to distribute this minus sign. So the way I like to do these is I write out the first one completely, plus 3x minus 2. Then I note what my values are going to be here. So I'm going to get minus 2x to the third. So I line that up underneath this one. And then I get a plus x squared. So I do that under this. And I get a plus 4. So I do that here. A lot of times they'll have it so that it's either not in order or there's one missing. So anyway, we get here a negative x to the third. Alright, for the x squareds I get a 3x squared. I have just 3x here, and I get a plus 2. So, G. Table above gives the values of the quadratic function f for selected values of x. Which of the following defines the quadratic function f? So these are sort of your outputs and inputs, so you could test them out. When I plug in 0, I should get negative 6. For this one, it's true, right? When I plug in 0, basically this first part is going to disappear. All right. I'm supposed to get negative 6, so there's only 2 that work for that. A and D. The rest can be eliminated. All right. So now I just have to consider A and D when I plug in my next point. All right. So I'll plug in 1, and I should expect an output of minus 5. So I plug in 1 to A. 1 squared is 1, and then minus 6 is negative 5. I go into D. 1 squared is 1 times 2 is 2. 2 minus 6 is negative 4. So that does not work. A is the one that works. What is the median? Okay, so the median, we have to put them in numerical order. So start with the lowest, then the next lowest, then the next lowest, and next lowest, and next lowest. Good. Now that we have them in order, we can kind of do this trick here. We cross them out until we get either 1 or 2 left over in the middle. Here we have 2, so we have to take an average of those. So when you do an average, you add them together and divide by 2. Or you could sort of eyeball it, right? You're kind of going between 2 and 10 here. So 12 over 2 is 6. So you're getting 76. But yeah, you could of course add them and divide by 2 as well. For all numbers x and y, let the operation symbol be defined by x symbol y equals this. Which of the following can be equal to 0? Alright, so this is actually quite a tricky question. So we have A symbol B. So we have to follow the instructions here. So it's supposed to equal 2 times AB, right? First times the second. Right? X stands for the first position, Y is the second, so you know. Then minus 4 times the thing in the first position, which happens to be an A. Now we're trying to see, can this equal 0? So what we do is we'll try to solve. Okay. We can factor out a 2a. We're left with b minus 2. So if this equals 0, we can kind of t-chart this, right? And then if 2a is 0, that means a is 0. If b minus 2 is 0, that means b is 2. So one of these might be possible. So a and b, so here's our constraint. A and b have to be positive. Okay. So in this case, we reject a equals 0 because that's not allowed. It has to be a positive number. B equals 2 can work though. So that means that if b was equal to 2, the original thing we had would have to equal 0. So we found a way to make it equal 0, so we can put a check mark. And we can also eliminate anything that doesn't include 1 in its answer. Right, so now that we've done that, we can repeat this process for the second item on our list. So a minus b, symbol b. So again, we have 2, and then x represents the first item, which is in this case a minus b. Then we multiply that by y, which in this case is b. Minus 4 times the first item, which is a minus b, right? Good, so now we have to see, can this equal 0? So again, we're going to kind of use a similar logic here where we're going to want to factor. So here we kind of factor out a 2 along with an a minus b. And what's left over here in the first position is b minus a 2, right? So again here we could t-chart this situation, and the 2 just drops out because we divide by 2 on both sides. So here we would get a equals to b, and here we get b equals to 2. So in either of these cases, in this or this, we would get a solution of 0. So can either of these be possible? The answer is yes, right? So whatever I choose for a, and if I choose the same thing for b, let's say 1 and 1, the original would be 0. Or I could just have a be anything and b would have to equal 2, and the whole thing would be 0. So this gets a check mark. So now we can eliminate yet another choice. And really it's just down to whether 3 works or not. So we'll repeat once more. Alright, so this time we're doing b symbol a minus b. By the way, this question takes a lot of time, so if you realize that and maybe have trouble with it, you might want to just skip it while you're taking the test, right? But anyway, 2 times the first thing, which is x, times the second thing, which is a minus b, right? Minus 4 times the first thing, which is b. We want to see if this can equal 0, okay? In this case, we could factor out a 2b. We're left with is a minus b from the first piece, then minus a 2 from the second piece. Alright, so then we could t-chart. Again, the 2 just disappears, divide by 2 on both sides. B equals 0 is one solution. The other solution is that a minus b would have to equal to 2. Alright. And b equals 0 is not possible because, again, they have to be positive integers, right? But so long as their difference is equal to 2. So I can make a be 4 and b be 2, for example, and this will then be true. So I found a way to make that true, so my answer is E. In the figure shown below, the measure of angle SRT is here, is x plus 15. Okay. The measure of angle SRU is 90. What is the measure of TRU? All right. So TRU is the difference between those angles, right? Because if I went the full 90, but then I subtracted away the x plus 15, what would be left over is this, right? And another way to say that is, let's say we call this y, right? Then x plus 15 plus y would have to equal up to 90, right? So then if we solve for y, we'd have to subtract x along with 15. Alright, so 90 minus 15 is 75 minus x. Alright, so here 6a minus 12, we have to distribute the minus. So we get minus 4a and then minus 4. And then, so 6a minus 4a is 2a. And then these are both negative, so they add up to 16. Then I can factor out a 2 and get a minus 8. Alright, in the standard coordinate plane below, these points are the vertices of a parallelogram. What is the area? So the area formula is base times height. Right? So the base measurement is this bottom part here, and it looks like it's going to be going from x of value of 0 to x value of 8. So I'm going to put 8 here. Now the height, by the way, is not slant height, it's actually the direct vertical. Okay? So the vertical, it starts at a height of 2 and it goes up to 6. So I claim that this height here has to be 4. So then we just simply substitute those numbers in. 8 times 4, so that's 32, right? Which of the following expresses z in terms of x? So we have x to the 5th equals y, and we have y to the 3rd equals z, and we want to know what z is. Well, here, z is y to the 3rd. But we'd rather not have it in terms of y, we'd have it in terms of x. So we'd like to plug something in for y. So we'd have to take this equation to start out, and then plug the x to the 5th in where we see y. So x to the 5th to the 3rd power equals z. Now we use our exponent rule 3 to multiply the exponents together. So we get x equals, or z equals x to the 15th. Which of the following statements is not true about this geometric sequence? Right? So geometric sequence, you recall, is a sequence in which to get to the next term you multiply by some number. So the first thing we might want to do is figure out what that number is. So in this case it looks as though we're halving each time. So that is, we're multiplying by 1/2. So our common ratio is 1/2. That rules out choice H because choice H is true. The fourth term is, so that would be the next term beyond this. So we multiply 9 by 1/2, and if your calculator is right, it'll be 4.5. All right. Each term is evenly divisible by 3. Well, that's not true, because we just came to a term here which is not divisible by 3, right? So we see I avoided the sum question because that takes a little bit more work. But yeah, we found one that's false. For the right triangle below, what is the tangent of C? So the tangent from SOHCAHTOA, we know it's opposite over adjacent. So we go to the opposite side first, which is here, then the adjacent side, which is here. Now, the opposite side is 9, and the adjacent side is 5. 9 over 5 would be our answer, so choice E. The area of the trapezoid is found by using this equation. What is the area of the trapezoid shown below? Okay, so we need to know each base and then the height. So fortunately we already know the height, and we already know one of the bases. We just need the other one. Okay, so what I would do here is I would actually draw another dotted line here and say that that height is 4 as well. So here we have sort of a 4 and a 5 and an unknown here. So if you know your special right triangles, you should be able to identify that this is equal to 3, because that would make it a 3, 4, 5 triangle, right? Same thing here, also 3. And then this middle part is 6. Now if you didn't know the 3, 4, 5 triangle, you could also use Pythagorean theorem to find this value. Okay. But anyway, so the total base here at the top would be 3 and 6 and 3. So that would be 12, right? So we'll call that B1. And then base 2 is 6, and then our height is 4. So now we could just plug into our formula, which is, as we see here, half height times the sum of the bases. Half height times the sum of the bases. So if I plug in 4, 4 over 2 is 2, right, half the height. Then the sum of the bases is 18, so I get 36 for my area. The diagonal of a rectangular garden is 15 feet, and one side is 9 feet. What is the perimeter? So the first thing I would want to do is I'd want to find this bottom side here, and so I could use Pythagorean theorem. But before I do, I always like to check to see if there's a special right triangle. In other words, a Pythagorean triple. So my first one to check is 3, 4, 5, and then I could check any multiple of that. So in this case, I would multiply by 3, okay, 9, 12, 15. Multiply each of these by 3, and then I find that 2 of those match up with this. So the missing one would have to be that, 12. And you should be a little bit cautious there just to make sure that 12 is not the hypotenuse or something weird, but almost always, yeah, this will be a nice way to solve this. But anyway, now the 12 would also go here, and the 9 would also go here, and we just find the perimeter by adding all those up. So we get 24, 34, 44, but then I have to minus those two, so 42. Right, so here we have to FOIL, and what I prefer to do is instead of 1/3 a, I write it as a over 3. Same difference, right? A over 3, okay. So now we do first, we get a squared over 9, and then we do outer, that's minus ab over 3. We do inner, that would be another minus ab over 3. And we do last, we get plus b squared. These two middle terms can combine. So you have one ab over 3 and another ab over 3, you get 2 ab over 3. Right? You could treat that whole ab over 3 as the tail for your like terms. And so what we end up with, if you really think about it, is just 2/3 AB here in this position. Negative 2/3, that is. So we're in between these, and a squared over 9 is really 1/9, right? So, yeah. Which of the following inequalities defines the solution set for this? Okay, so we could start by subtracting 23. So that'll get us negative 18, I believe. Then we could divide by negative 6, and we have to remember when we divide by a negative, the inequality sign will switch from greater than to less than. Okay, so we get x is less than or equal to 3. What is the approximate distance between these points? Okay, so now we get to use our new distance formula, which is d squared delta x squared plus delta y squared. So delta x means change in x, which usually you do like x2 minus x1 or whatever, but I have a nice way of doing it, which is a little shortcut. So 4 and negative 6, right? Right away I know it's 10. So let me explain how I know that. So negative 6 to 4, I know I have to pass 0. So I have to go 6, and then I have to go an additional 4. And of course that adds to 10. So the shortcut is, if you ever have a situation where the signs of these numbers are different from each other, then you can add the absolute values. And by absolute value I mean just look at the number part, not the sign. So we take 6 and 4 and add them, you get 10. And in this case we could do the exact same thing because the signs in front are different for our y values. So we add 5 with 3 and we get 8. Alright? So now we can consult our calculators, and we can do 10 squared plus 8 squared. We get 164. We take the square root of that answer, and we get 12.8. The ratio of x to z is this. So the ratio of x to z is interpreted as x over z. Is equals 3 to 5, 3 over 5. The ratio of y to z is 1 to 5. What is the ratio of x to y? Okay, x over y is question mark. Right, so very important to know math English wise what ratio means. Okay, but from here, right, there's a few ways we could solve it. So let's look at perhaps the long way first, and then we'll look at the other possible short ways. Okay. So the long way is we could solve for x, and we could solve for y, and then we can plug in. So solving the first equation for x requires me to move the z to this position here, right? So that would give me x equals 3z over 5. Now I can plug that in for here. And similarly, I can move the z across diagonally to the top of this, and I get this for y, which I can plug in there. Now I can use my keep change flip, and the 5's will cancel along with the z's, and therefore I'll just get 3 as my answer. And so that's equivalent to 3 to 1, right? So now that was option 1, which is what I consider the long way. Okay. So now let's reconstruct what we had originally, which was this and this, right? So now let's look at the second way, which is actually my preferred way to solve this. So since I'm looking for x over y, I know I have an x over z, and if I flip both sides here, I'll have z over y equals 5 over 1. You'll see why I do that in a second. Basically, if we multiply these left sides together, notice what happens. We get xz over zy. I mean, the z's will cancel, leaving x over y, right? And that's kind of nice. So all we have to do really is to multiply then the right sides together. And 3 over 5 times 5 over 1, notice how 3 over 5 times 5 over 1, the 5's will cancel, leaving 3 to 1 as our answer. Okay, so that's pretty neat. So that's way 2. So now let's have a look at way 3. So the third way works only sometimes, but in this case it's kind of nice. So we can sort of see that z corresponds to 5, and that z also corresponds to 5 here, right? So we can let z equal 5. So that we know that z is 5, right? So as long as these kind of match up, the other ones will too. So if x equals 3, y would have to equal 1. So that's a 3-to-1 ratio, right? That's not a preferred way for me, but I've seen some students like that method. If tangent of alpha equals x over y, and alpha is between these two values, what is the value of cosine of alpha? Okay, so let's see. Yeah, so we start here. We know that we're in the first quadrant, okay? So we could draw our sort of vector here, and then draw our line coming down, which is our reference triangle, right? This is 90 degrees, or otherwise pi over 2, and this is 0. So then, here's our angle alpha, and we know that tangent is x over y. Now, tangent is opposite over adjacent, so this is opposite, this is adjacent. Now, we're also looking for the cosine. So the cosine is adjacent over hypotenuse. So we need to figure out what the hypotenuse is. We could use Pythagorean theorem. So let's call it h for hypotenuse. So h squared would equal x squared plus y squared. So we know then that if we solve that for h, we get h equaling the square root of x squared plus y squared. So let's plug that in for h. Whoops. So we get x squared plus y squared square root. Oh, it's kind of terrible. X squared plus y squared square root. Okay. So now when we're looking for the cosine of this angle, we want adjacent over hypotenuse. So we want y over this. And that is choice G. All right, 47. In the figure below, this is a square, and these are the midpoints. If GH equals 10, all right, so the thing is a square, so we know also that this is 10, and pretty much all around is 10. Okay. What is the area of the inner square? Well, we at least think it's a square, right? And we know that these are midpoints, right? So we can actually say that this is 5 and this is 5. This is 5 and 5, 5 and 5, 5 and 5, right? So now here's where our knowledge of special right triangles is going to help us out. So we have a special right triangle which is 45, 45, 90. And if you notice, that's sort of appearing here, right? We know that this is isosceles because 5 and 5. So we know these base angles are equal, and we have a right angle in the corner here. So we can then ascertain that x rad 2 is our ratio of sides. So we know that this is going to be a 5 radical 2 on this side here. The same logic will get you a 5 rad 2 in this position. And then to find the area, we just multiply those together. 5 rad 2 times 5 rad 2, whoops. 5 times 5 is 25. Rad 2 times rad 2 is 2. 2 times 25 is 50. So, by the way, when you see 5 rad 2, you should think of that as 5 times rad 2, really. And then, so yeah, it's like 4 separate factors. And that's why I can do the 5s first and then do the rad 2s. But anyway, yeah, the answer is 50. Now, if you didn't know about this 45, 45, 90 stuff, you could have also done a Pythagorean theorem on 5 times, so 5 squared plus 5 squared square root. So you would have gotten the square root of 50. So you'd have had rad 50 times rad 50, and you would have gotten the same answer of 50. In the XYZ triangle below, XZ is, so XZ is 7/8 of H. So when we see XZ, we could label that as 7/8 H. What is the area? Okay, so they want the area. So we know the area formula for a triangle is 1/2 base times height. And I prefer to write it like this, base height over 2. Now, the base is going to be equal to this, and the height is just h. So the base is 7h over 8. The height is just h. And then we have to divide that by 2. Alright, so this gives us 7h squared over 8 divided by 2. And now we have a fraction over a number, and to fix this, we make the number part a fraction as well by dividing by 1. Now we can use our keep change flip. We get 7h squared over 16. Okay, that's our area. So another way you could sort of interpret this second step here is, so you can do 7h over 8 times h, and then instead of dividing by a new 2 here, you could just realize that this is sort of an artificial separation. You're separating a multiplication from a division. You can just bring this thing across, right? And then, instead of introducing a new denominator to divide by 2, you can see that you already have a denominator. So just put the 2 down bottom. And then you get the same result, 7h squared over 16. On Friday, a computer was priced at $800. On the following Wednesday, the price was reduced by 15%. So a 15% decrease. In other words, 15% off. So to find the multiplier, we look at percent on. So it's going to be 85% on. So that corresponds to a multiplier of, move the decimal twice, 0.85. Right? Good. On the following Friday, the price was further reduced by 20%. So that's 20% off, okay, which is 80% on. So that's going to be a multiplier of 0.8. What percent of the original price was the final price? Okay. No problem, right? So what we do is, normally we would start with 800, which is the original, and we multiply by the multiplier. That will give us the final. In this case, we have two multipliers, so we just tack on the next one. Right? So this, if they ask for the final price, this would be the perfect thing to do. If they ask us for what percent of the original price was the final price, right? All we really need to do is find the combined multiplier. But if you kind of didn't see that, then we could look at it like this, right? Well, let's see. So let's interpret this in terms of math English. So the word what, the word percent divided by 100, of is times the original price, so we'll call that orig, was means is or equals the final price, so final. And then we solve this for x. So basically we would have to divide by original, so that would go diagonally downwards, right? And then we'd multiply by 100, so that would come to here. So that's our answer, sort of x, right? Final over original times 100. So now we could look at what we have here and try to sort of get it to look like that. So we would divide by original. Right, let me just move this over. Okay, so we divide by original, or in other words, move it diagonally downwards. Then we multiply the left sides in our calculator. So we get 0.85 times 0.8, and that's 0.68 equals final over original. Where did the 100 go? Sorry, this should be times 100. Oh yeah, sorry. I would have to then multiply both sides by 100 to actually get my answer. So 68 is equal to this expression, which we know is x, right? So the answer is choice B. But of course, instead of doing all that work, you could just interpret what they're asking for is kind of the final sort of combined multiplier, which, as we just saw, is 0.68. So the way to interpret a combined multiplier is this is the percent that you're actually going to be paying. It's your percent on. So it's 68% on, right? And this is technically what the question is asking for, right? What percent on is it? What percent of the original price was the final price? What percent do I still have to pay, right? Whereas if they asked for the percent off, we would then have to take its complement with respect to 100. So this corresponds to actually a 32% off. So we have to be careful about what they're asking for. All right, question 50. GHJK equals 24 and GHKL equals 0. Which of the following must be true? Alright, so we know that one of these guys has to be 0 for the product to be 0. However, G and H are both appearing in this one, and they didn't cause this to equal 0. So we know that G and H both are not equal to 0. And also K, right? So let's see. So that tells us what the culprit is, right? L is the one that's causing this thing to equal 0. Given the vertices of parallelogram below, what is the area of the triangle, right? Area of a triangle formula is base height over 2. So we need the base. So GHJ. So the base looks like it's going to be here. Notice the y values are the same, so we just take the difference of the x's, which is 4. And then the height, we don't want a slanted height, we want a perfectly vertical height. So we just look at the sort of y values here. We don't care about like finding a distance formula here. We just want the vertical drop. So we went from 3 to -8. That's a distance of 11, right? So 4 and 11 are our parameters here. 4 times 11 over 2. 4 over 2 is 2. 2 times 11 is 22. X, y, and z are real numbers. X, y, z equals 1. Then which of the following must be true? Well, x, y, z equals 1. Right away, I'm sort of thinking about manipulating this equation, moving things around, right? If I move the y to the bottom here, then I get xz, right, diagonal. Xz equals 1 over y, which is the first choice. In the standard xy coordinate plane, the y-intercept of this is. So to get the y-intercept, I'd have to subtract 6x first. Alright. And I get 2y equals minus 6x plus 14. Then I divide by 2 in every single spot. So that can be y equals minus 3x plus 7. So the y-intercept is just 7. So average, so right away we write our average formula of a set of 6 integers, so we know number is 6. The average is 38, so that goes in the average position. So right away, before I even read on, I'm going to find out what the sum is, because 99% of the time I'm going to need that value. 38 times 6, 228. When a seventh number is included, the average, okay, so now we need another average formula. So again, average equals sum over number. This time we have 7 items, all right? And the new average is 47. So instead of sum, we'll call this sum 2 to distinguish it from the first sum. So we have to do the cross multiply here. So 47 times 7, all right, 329. So sum 2 equals 329. What is the seventh number? So at this point, you realize that this is a sum of the first 6, and this is the sum of the first 7. So the way to figure out the missing number is to just subtract these totals, right? It looks like it's going to be 101. The area of a rectangle, which we know to be length times width, is 80 square feet. If the length of the floor is 4 feet less than 4 times the width. So usually we'd think of this as 4 less than 4 minus 4 width. But when we use the less than, we have to remember to switch the order. So it's really 4w minus 4. And if you weren't sure about that, let's say 10 less than 100. If that were the case, you'd know the answer is 90. So really what you did is 100 minus 10. And this is a good idea if you're not sure how to convert from the words into math. And one thing you can do is you could sort of use that idea of sort of using numbers to figure it out and then understanding what the operation is and applying that to your symbols. But anyway, we want to know what the width is. So width equals question mark, right? Now we have a 2 by 2 system here because we don't need the letter A. We just use LW, right? Then we could take this and we could plug it in for L here. So 4 times W minus 4 times W is 80 This w distributes. 4w squared minus 4w is 80. Then, since this is quadratic, we want everything on the same side. So we swing the 80 to the left-hand side by subtracting it from both sides. At this point, we want to factor this down. So we factor out of 4, and we get w squared minus w minus 20 equals 0. Then we could further factor by doing a trinomial. w, different negative, and the numbers would be 5 and 4. Right? They multiply to 20 and combine to 1. Now, we could just divide by 4 on both sides, would get rid of this, and then t-chart, w would equal 5 or negative 4. Negative 4 we reject since it's a length, or width in particular, but so we take the width to be 5. We always double check what that's asking for, which is the width, right? Okay. Let me just erase this. For every cent increase in the price of a pound of apples, the grocery store sells 25 fewer pounds per day. Okay, so right away you could tell this one's going to be tricky. The grocery store normally sells 800 pounds of apples per day at $1.09 a pound. Which of the following expressions represents the number of pounds sold per day if the cost is increased by 3x cents per pound of apples? Okay. So one thing you could do to actually make this easier is to pick a number for x. So you pick x equals 2, or any real number, and you could then plug that in, and that would sort of give you, when you finish the problem, you'd get an actual answer, let's say 75. So it wouldn't match up with the choices. But then you plug x equals 2 into the choices and see which ones equal 75. So there may be one, or there may be more than one if you're unlucky. So if you're unlucky and you say that these are both 75 when you plug in x, then you'd have to actually do the whole thing again, choosing a different value of x. But that process, while useful, is not quite the correct way to do it. So let's see if we could do it the correct way. The grocery store sells 25 fewer pounds per day for every cent increase. So if we increase by 3x cents, right? So if we did 1 cent increase, that's going to correspond to 25 fewer pounds. So if we do 3x cent increase, then how many fewer pounds is it going to be, right? So we could sort of cross multiply here, and so we get question mark equals 3x times 25, which is really 75x. So it's going to be 75x cents fewer than what it originally is, right? So which of the following expressions represents the number of pounds of apples sold per day? Sorry, this is not going to be cents, is it? It's going to be, so the cents cancels. It's going to be fewer pounds. Sorry, fewer pounds. Fewer pounds, okay. So the original amount that we sold was 800 pounds, right? And we know we're going to have 75x fewer pounds. So we do 800 minus 75x. Okay? So notice we don't even need the $1.09 per pound. We're not caring about the price or how much revenue we're raising here. What we're concerned with is the number of pounds. So looking at the units really helps there. Jason has been hired to build a circular wading pool in his neighbor's backyard. The rectangular backyard measures 60 by 50. Jason's neighbors want the pool to be as large as possible, with the edge of the pool at least 8 feet from the backyard all around. So the most restricted dimension for the pool is going to be this vertical. Alright, so we need to leave 8 feet here, and also 8 feet here. So vertically, we have a total of 50, but we have to take away 16. So really we only have 34 to work with, and that's going to make up the diameter here. So half of that will be equal to the radius. So the radius would be 17, and that's what they're asking. If f of x equals this, what is f of x plus y? So x plus y would have to go in for x. This gets squared and then add 3. So then you can actually FOIL this out. Alright, so you do the x times x, get x squared. The outer is xy, the inner is xy, and the last is y squared. And so then you can combine these xy's to make a 2xy. And that's choice F. In a game, 84 marbles were numbered 0 through 83 are placed in a box. A player draws one marble at random from the box. Without replacing the first marble, the player draws a second marble. If both marbles have the same tens digit, the player is a winner. If the first marble Dave draws is 23, what is the probability that Dave will be a winner on the next draw? Okay. So basically they have to have the same tens digit, right? And the tens digit here is 2. So we need to have a 2 in the other digit. So let's see how many other marbles there are with that. So 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. These are all the possible marbles with a starting digit of 2. Tens digit, that is. Now, the marbles weren't replaced, so this 23 is now out of commission, so to speak. So the number of marbles with which he can win appears as 9, right? 3, 4, 5, 6, 7, 8, 9. So there's 9 winning marbles left in the box. Out of how many marbles are left? Well, the numbers 0 through 83, that's 84 marbles, but we already took one out, so there's only 83 left. So this is our probability. What is the smallest possible value for the product of two real numbers that differ by 6? So two real numbers differ by 6. So let's see. Well, so xy is what we want to minimize. So that's our objective function here. We want the two things to differ by amount 6. So let's think of two numbers that differ by 6. How about 7 and 1? Right? They differ by 6. Their product is equal to 7. So I found a way to get 7. Right? That's a possibility. What about, can I use the numbers 6 and 0? Right? Is there anything that's telling me I can't use 0? No, right? So if I use those two, the product now is 6 times 0, which is 0. So now I found a way to get 0. Can I do any better? Well, what if I use 5 along with -1? The difference of those is equal to 6, right? Because if I look in a number line, -1 to 6, we have to pass 0. So we have 1 and then 5 more for their difference. So anyway, sorry, that was supposed to be to 5, not to 6. But anyway, the product here would be -1 times 5 is -5. So we found a way to get this. Let's see if we can do any better. What if we do 4 minus -2? That's equal to 6, right? And the product here would be -8. Can we do any better? How about go down 1 here, go up 1 here? 3 times -3 is -9. So that's about as good as I could do.